Hey guys, AP here, and today we are going to be continuing our Lightweight Java Game Library 3 tutorial series. So from the last tutorial, you should have gotten a mesh rendered, which is just literally a white rectangle in the center of our screen. But what we're going to be implementing today is some shaders. So what shaders are, basically, is they run for each and every single little vertex, of a mesh. So these are the four main ones, but it also runs for each of the ones that we haven't defined. You know, the ones like in the middle of the rectangle, like, let me run this again. So it runs for all this like mesh stuff, basically. It runs for all the white stuff. So let's start making that. So how shaders works is basically we have two external files for the Vertex and Fragment shader. There's many other types of shaders. There's geometry shaders, there's tesseract shaders, but for right now we're only going to use two of them, which is called a Vertex and a Fragment shader. So we're actually going to make those in our file or our project, basically. And so in here we're going to say new source folder, because this is going to be one of the main folders, and we're going to call this resources. Now, this has to be called resources. It can't be called anything else, because we're going to do something very specific in our file loading system. So in resources, we're going to create a new package called shaders. And this is where all of our shaders are going to be for our game. So in here, we're going to say new file, and we're going to call this file main vertex.glsl. Which basically means, for the extension, it means GL as an open GL, and then SL means shader language. So graphics library shader language, which is generally the standard. You can have like .vert or .frag for each one, but I'm going to use GLSL for all of them. So in the main vertex, we're going to have a couple things. We're going to have ourselves a main function, and so that's going to be called void main, and have parentheses and some curly brackets, and this is where we're going to define everything at. But for right now, this is all we need, and also we need the same for the fragment. So what we're going to do is we're going to copy the vertex, and then we're going to paste it again. Instead of calling it main vertex, we're going to call it main fragment. And since I copied it, we should have the void main in there. Alright, I'm just going to do that because it keeps popping up. Anyways, so now that we have the two shader files, we actually want to load them into our program. So to do that, I'm actually going to make another package, and this is going to be called, actually not engine, go to engine.utils. And this is basically where all of our helper functions are going to be, like for loading files, for creating things, but for right now we're just going to put this in utils. We're going to create another class called file utils, is what I meant to say. So file utils, and this is basically where all our helper functions, like I said. So we're going to do public static, since we really don't want to create a file utils class, public static string, and then because we want to return a string when we load a file, load as string. And basically what this does, or we also need to have a argument that sends us to the path. And so what we want it to do is we want it to go to that file in the path, which is going to be in resources, and we want it to give it what's in that as a string. So to do that, we are going to use a string builder. So what a string builder is basically a string, but it's meant for files and adding on and deleting and all that. So string builder, we're just going to call it results, and we're going to just say this is a new string builder, which basically initializes the string. So string builder, let's import it. Oh, it's already, okay. So string builder's already there. Okay, and then what we're going to do is we're going to return result.toString. So now that we have that, it should give us no errors. And now that we have that, we can actually put stuff in our result string builder. So to do that, we need to have a try catch, because the path may lead to no file, and we don't want that. So we want to have a try catch loop to make sure that that doesn't happen and break our program. So in the try, we're going to try to make a buffered reader. So to do that, we're going to say buffered reader, and we're just going to call it a reader. It's going to be equal to a new buffered reader, and this is once again where things get different from my last tutorial. We're going to say a new input stream reader, and then in here, we have to import it. In here, we are going to say get resource as stream, but this has to come from a class. So we're going to use a default class, which we have to get its class, and then we're going to say dot get resource as stream, and then wherever the path is. So now we have this long line right here. It basically makes a reader for a resource as stream. So what this does is it goes to the resources file or folder, and it gets whatever you want, like from path. And so this is going to be an absolute path. So if we do a relative path, that means it's going to be searching for in the utils packages, which we don't want. We want it to actually go to our resources. So resources or slash shaders slash whatever shader we want. So to actually read this, say it went actually successfully, we want to say while there is a line, we want to say while line is equal to reader dot read line, which basically stands for we want to read the line, and if it's not equal to null, so not equal to null, meaning there if it actually exists, we want it to actually add it to our result string builder. So result dot append line. So with that, we have to say string line. We have to freaking string line is equal to no line. There we go. So stop complaining. And so while there is a line, we wanted to append the line, but we also want to do after each line, we want to have ourselves a character or line break, which is this back is that forward slash? That's forward slash in, which is basically a line break, and we want to do that after every line, so it actually keeps the white space and all that. So, and then that's it for our while loop, because once the line is not there anymore, then it will get out of this while loop, and it will get out of the try catch little syntax here, and then it's going to return whatever we did. So say we couldn't find it, which this is going to be called an IO exception. So IO exception, we're just going to call it E. With here, we're going to say E, or we're not even going to do that. We're going to say system.error.println, and we're going to say couldn't find the file at whatever the path is, so plus path. So there we go. Now we have ourselves a load as string function, which gets us the contents of a text file or a shaders file. So now that we have ourselves a file utils, what we're going to do now is we are going to actually make a shader class that holds two shaders. So in graphics, because this is where I'm going to put the shader, I'm going to say shader, and the first thing we need to do is have a constructor that gets the paths of the two things. So to do that, we need to say public shader, and then we need actually to get two variables. They're going to be both strings, so private string vertex file, and then fragment file. So this is going to store the content of our files. So to do that, we need to say string vertex path, a fragment path. So in the constructor, I'm going to be calling the file utils function that we just created to actually store what's in each file. So vertex file is equal to file utils dot load a string and then whatever in the vertex path. And same goes for the fragment. So fragment is equal to file, or fragment file is equal to file utils dot load as string fragment path. And so with this, we can add a new function called create, and with that, we can actually start making our shaders. So public void create. So here we need to actually create a few more things. So these are going to be pointers basically to our shaders and what is essentially called a program. Now what a program is, it's basically all the shaders compiled together to send off to the graphics card to actually run the shaders. So we need the vertex ID, which is our pointer for the vertex shader, fragment ID, once again for the fragment shader, and then the program ID, so we can actually send it off to the graphics card. So in our create function right here, we are going to actually initialize them. So the first, we need to actually do program ID is equal to GL20 or GL 2.0. That's when shaders were introduced. GL20 GL create program, and now we don't need any arguments. It just creates the program. Now for the vertex ID or the vertex shader, we need to say the same thing but shader. So GL create shader, and this one actually does have an argument, which is what type of shader do you want to make. And since we know it's a vertex shader, we can say GL20.GL vertex shader, which is all the way down here, and that's all we have to do. Now I'm just going to I'm actually going to make the vertex shader real quick, and then I'm going to make the fragment shader. So after we create the shader, we're actually going to set the source code of the shader, which, as you know, we stored in this vertex file variable. So the next thing we have to do is we have to say GL20.GL shader source, which shader do you want to attach it to, which is our vertex shader, and then whatever is in our file, which is the vertex file. And then after we attach that source, we need to actually compile the shader. So GL20.GL compile shader, and then we're going to compile the vertex shader. Now this is where we're going to do some error checking, because in here we could have some errors, like say we have like some random typing here. We actually want to know if there's an error, so we're going to do what is essentially called error checking, which we're going to do using GL get shader I, which is shader info, and then what shader do you want, which is our vertex shader, and then what is the argument you're going to be testing, which is did it actually compile. So that is GL compile status. So with that, we want to actually see if it compiled or not. And since GL likes using their own true and false, we're going to just say is equal to GL11.GL false. So that means if it didn't compile, import GL11. If it didn't compile, do whatever is in here, which is don't continue creating it because there's an error. And to actually make this useful, we're going to print out that error. So system.error.println, we're just going to say it's in the vertex shader, because what they do is they just say it's an error, but they don't show where. So vertex shader, and then plus GL20.GL get info, or get shader info log, and then the shader we want to get, so the vertex shader. And so what this does is if it didn't compile right, it gives us the error that it didn't like, and then it stops creating it because it can't go on without a vertex shader. And so now we're going to do the same thing but for the fragment. So copy all this and just replace vertex with fragment. So to just say fragment, and then here's GL fragment shader, fragment ID, fragment file, and then fragment ID, fragment, compile same, fragment, and fragment ID. So now we have the same thing essentially, but for the fragment shader, which they're not really that different. They just do separate things. And so the next thing we got to do is we actually have to attach these shaders to our program that we created up here. So to do that, we need to say gl20.gl attach shader, whatever program we need, which is our program ID, and then we're going to attach both the vertex and the fragment. So we can't do it at the same time. We have to call it 2 separate times. Oh crap, I thought I had fragment still copied. Well, I didn't. So now that we have the vertex and fragment shaders all done, we need to link the program, which basically means that can we actually attach these shaders. So gl20.gl link program, and then whatever program, which is ours, and then we need to do gl20.gl validate program, which basically is just a bunch of steps to make sure that the programs is not messed up. Now we're going to do some more error checking with this, but of course it's going to be a little different because now we're messing with programs instead of shaders. So if gl20.gl get program I, and then whatever program is, and then whatever we're testing for, which is linking, as you remember up here, so gl20.gl link status is equal to gl11.gl false. Then we need to return, so we don't want to continue on, and then we also want to say system.error.print line, and then what is it? It's going to be called program linking, and then we're going to return the program info. So gl20.gl get program info log, and then whatever program. So now we can actually copy and paste this because it works for the same for validate, except it's called validate. So validate, can't type, and then say validation. So now we have all the shader code done. It's all created and it's all error checked. So that means after we do all this and it actually works, we're going to get rid of the shaders because now we have a program that does it all for us. So gl delete, not program. We need that when we delete when we say destroy. So delete shader and then whatever the shader is. So vertex ID. So we have to do the same thing for the not the vertex, for the fragment. So .gl delete, dang it, fragment and shader. So that means we're all completed and we have a compiled program that works. So to actually use that program, we actually have to bind the shader to whatever we're drawing. So public void bind, and then after we're done drawing, we're going to unbind it. So unbind. And so this is basically a shader wrapper. It wraps this shader code function, which is gl20.gl use program. And then if we're binding it, we're using the program that we created. If we're unbinding, then we're just going to set it back to 0, because that just means there's no program binded. And so after, we're also going to create another one called public void destroy, which deletes the program. So gl20.gl delete program. That's the first time I actually wanted the delete program function. And so basically, for this tutorial at least, we're done with the shader class. So we're going to make our first shader. So we're going to say public shader, and we're just going to call it shader for right now. And then we're going to make it in here. So actually before render, because I want to do something with the renderer with this. So shader is equal to new shader, and then we need paths to the vertex and the fragment. So to do that, we need to say, since we already have the resources, we just need to say slash shaders slash main vertex dot GLSL GLSL. And so same for the fragment, but you know it's called fragment, so fragment, and then import shader. So there we go. Now that we have our shader, we're going to create it. So shader.create. And that should be it. So before I actually render it, I'm going to do something with this renderer class, because later on down the road we're going to have specific renderers like a font renderer or a platform renderer and all of that. So we are actually going to pass this shader that we created into our renderer. So where's renderer? So in here we're going to create a constructor that takes it and stores the renderer. So public renderer, and go in here. We say shader, we actually need to store it. So private shader. We just say this dot shader is equal to shader, and then right here is when we're going to use it. So right before we draw the elements, we need to say shader dot bind, which basically means that we're going to bind the shader to what we're drawing to, and then after that we're going to say shader dot unbind, which gets rid of the shader and it gets ready for the next shader. So with that all complete, we could just run it and nothing should happen. You'd basically have no errors. Oh yeah, there is an error, because I forgot about no errors. Oh yeah, there is an error, because I forgot about typing this. Alright, hold on. Now we should get no errors. Oh, frick. Dang it. Now we actually need to write the shaders. I forgot about that. So with that, we can actually start writing the shaders. So the first thing we need to do is we actually need to define what type of shader code we're using. Now, the norm is to use the latest one, but since I actually know a specific one, which is just this one, version 330, which is, what is it, OpenGL 3, and it's OpenGL 4.6, I think. I'm just going to use this. It doesn't matter which type of shader code you use. If you want to use the newer functions, you can use a newer shader. I'm not going to be doing that, or if I am going to be doing that, I'll make it myself. But for right now, I'm just going to be using 330. So the next thing we had to do is we have to actually get our position from this. Now, if you remember, when we're rendering our mesh, we call it a function called GL Vertex Attrib Pointer. And I said in that tutorial, which was the last one, that this was meant for shaders. And so now that we're at shaders, we're actually going to use it. So right here, since we're using it, Vertex Attrib Pointer 0, which is basically index 0, we are going to access this by doing this. Layout, and then in here we're going to tell it what index what it is, which is location, and then the index, which is 0, and then we're going to basically define what the variable is. So since it's an attribute, we're going to say this is coming into the vertex shader, so in, and then we need to define what it is, which is a vec3, because remember the position is the x, y, and z, and then we need to give it a name, so position. So with all that, we can actually start writing vertex code. So in here, like it said in this error, you have to write to GL position or GL underscore position, and that basically makes it like vertex shader defines the position of a vertex. And so if we say GL position is equal to position, you're going to get another error. So if we run this, we close this out, you cannot convert from a 3-point to a 4-point. So basically, GL underscore position is a vector 4. There's 4 things into it, which is the X, Y, and Z, but also has a W for some reason, I don't know. So we actually have to convert this vec3 into a vec4. So for this, there's actually an easy function called a vec4, which takes in a vec3, and then you can just add whatever you want. So if we actually run the Vertex, or run the program, you're gonna see something missing. So our mesh has disappeared, which is not a bad thing. It's not a bad thing. It's just we haven't written our fragment shader. And so what this does is basically defines the color of each vertex. So we can hard code it saying it's going to be white. Like we could just say, well, we actually have to define what's going to be coming out of this fragment shader, which it has to be a color. So we're going to say just say out vec4 for the RGB and then the alpha. So out vec4, and we're just going to say out color. And so we're going to set this out color to whatever we want. So maybe like a white, a red. Well, not a red because our background's red. So let's do white for right now, and let's not make it any alpha. So out color equals that, and it's just going to give us a cool little white. So here we go. Like before, except now we can change the color of it. So say we want like, is that going to be yellow? I think that's going to be yellow. So now, yeah, we have a yellow little rectangle here, and I think we can change the alpha of it. So 0.5. So it's gonna, oh, well, I guess we can't change the alpha of it. That's pretty not neat. So I guess alpha's a different day. Anyways, there we go. So now with that, we can actually define stuff that goes through the vertex shader into the fragment shader. So instead of having one solid color, why not have it based on the position of the vertex on? So what shaders can do is you can actually pass variables through them. So if you say out, and then whatever it is, so vec3 color, and then you can actually get this through the fragment shader or whatever shaders you're using. So in vec3 color, and make sure that these are the same names. So out vec3 color, in vec3 color. And so now we can actually set whatever the color is to here, which maybe we want to say it's the position. So color equals position. And then now we can actually use the color in here to say out color equals vec4, and then whatever the color is, and then 1.0. So if we do that now, as you can see, we have ourselves a little colorful, it's not really colorful. Maybe I can do a little bit better. So let me, hold on, hashtag version 330 core. You don't have to do this. You don't have to, it's just, it makes it better. So with this, we can actually make this better. So vec3 is equal to position dot x 0, or let's do 1.0 position dot y, because we don't have a z yet. Let's see what that color is. It's kind of just green. Maybe it's probably because of the green is the one activated. That's not really that good either. Position. I'm just trying to make this a pretty color so I can have a good thumbnail, basically. So x minus position dot y. We may get some errors here. That's actually pretty cool, I guess. Position dot at, what do we reverse it? You basically get creative with whatever you want. Like you have this. Oh, it actually looks pretty good. I'll have that as my thumbnail. That's all right. So yeah. So I guess this is gonna be our thumbnail. So that's how shaders work. Basically, Vertex goes through all the vertices and changes the position, and the fragment shader changes the color. So there we go. So that's the tutorial all done. The next tutorial, we're going to be actually working on how to use uniforms, and we might actually use solid colored attributes like we did for the mesh, or for the mesh position, but instead colors. So anyways, I will see you guys later. If you liked the video, please make sure to leave a like. If you want to see more, please make sure to subscribe, and I'll see you guys later. Bye.